Our outdoor unit provides that 24 volts DC on wires S2 and S3, and then that 24 volts goes into our indoor unit. Indoor unit receives that 24 volts DC and sends back 12. And what we're doing there is establishing that serial communication. Now, things that can go wrong, right, when we are running that communication is cross wiring, right? So new installation related issues, cross wiring. If we run S2 to S3, right, S2 on our outdoor unit to S3 on our indoor unit, we'll run into problems. If we cross, S1 and S3, we'll run into some major problems. So making sure that we have that polarity, that we're landing on the same terminals on the indoor unit as we are on the outdoor unit, will verify that we have that proper communication structure.
This episode brought to you by Mitsubishi Electric Trane and the Metis HVAC Tech Show, bringing you technical information for Mitsubishi Electric VRF, ductless, ducted, and hydronic heat pump systems. Learn more at MitsubishiComfort.com. Well, hello, everyone. Thank you for joining us once again on Did You Know, the ESCO HVAC podcast. So we are privileged to spend some time with Mitsubishi Electric Trane, Bryn Rabtor. How are you doing?
Good. How are you?
Doing fine. Paul Chaves, how are you, sir?
I'm good, Clifton. How are you, sir?
I'm doing great. We're spending some time diving into some of the most common technical support calls in the industry, and we're very curious. What do you guys see on the technical support side of the industry as the most common tech support calls? That'll give us an idea of some things that we should all be looking out for and getting better with.
Sure. So it's actually kind of funny. You had asked about potentially covering this topic. So I reached out to one of our technical support folks down at Georgia, and I asked him for a list of the most common error codes or tech support calls that they run into. And he provided me a list of probably 15 to 20 or so error codes, whether it was commercial or residential. And when I went through that list of error codes, it boiled down to two different issues:
Really?
communication issues and drain issues.
Oh, wow.
Okay. Yeah. So for me personally, when I was, actually in a van as a service tech, I saw a lot of refrigerant related issues, and we can talk about that too. But when it comes to, what we see, what our tech support folks down in Georgia, when they're getting the phone calls, they're getting a lot of error codes for that communication fault and then for some drain related issues.
Wow. I mean, it's hard to imagine when we think about all of those calls, and we're talking tens of thousands of calls that come in annually, I imagine. And we can break it down into a couple categories, which gives us the opportunity to turn it into a couple training opportunities.
Yep.
I know myself, I was a distributor trainer for quite a while. And so I worked with some the different manufacturer, but I can tell you from my own technical support calls, that whole communication was really the main one. And it was
Really?
typically in our lower voltage communication circuits. It's like when we changed from AC voltage into DC voltage, our brains just tuned out. And we kept thinking about DC like AC, and it's not. Paul, you had mentioned in a conversation we had on a separate podcast about how AC and DC flow through switches differently. And when we think about a legacy 24-volt AC system, that's all we were doing. We were using current to
Yeah.
control switches. And so we had load passing through them. So if I had a corroded wire, or if I had an old nasty wire nut, if I got enough load, I eventually passed through that resistance.
But right. And you hit the nail right on the head. The HVAC guys, are my age, maybe, I don't want to assume anything, but maybe your age too, Clifton. We used to dealing with electrons flowing, and we can handle that. We know how they work. But now we're talking about ones and zeros. Not electrons, ones and zeros. It's
load.
it's data. So now something as simple as a wire nut where it shouldn't be can interfere with that data. The wire that's too big or too small can interfere with that data. Whether the wire is solid or stranded. So these are the things that typically with electrons we don't care as much as we do when it's communication.
Yeah, absolutely. I always kind of refer that to think about like a fiber optic connection, right? We think about like the internet that we're using right now. My father, he was a heavy machinery operator, and one of his biggest concerns was hitting a fiber optic cable. That's what in that early generation of engineers, that they were most concerned with hitting fiber optic. You could hit a water line and you could patch it. You could hit an electrical line and you can patch it. You hit a fiber optic or a communication line, you're not going down there with wire nuts.
Nope. Nope. Yeah, exactly. It's a whole new run, which we
It
see a lot on our side of things too. So
it is. And so for at least the calls that I was working with, what I would have to explain was when we had load passing through, we had a lot more fudge factor. We had a lot more lenience on poor connections, wire that had been chewed through by a mouse and was all oxidized on the surface, wire nuts that have had moisture in them. Those things were not as critical with an AC voltage. But when we moved to DC, it immediately became high priority, and our ground connections as well, because many of our communicating circuits are utilizing ground as a reference point, for their signal. And so when we make that shift into communicating, we might think that it's a communication problem with the equipment, and then we go, "Oh, I'm stuck on this communication problem." But what do you end up seeing in a lot of those calls? What are a lot of the common responses that you end up having in those calls for communication?
So typically, and I think it is, somewhat useful to know just the basics of how the communication works, right? And we have discussed it on a previous podcast, but just to simplify, our outdoor unit provides that 24 volts DC on wires S2 and S3, and then that 24 volts goes into our indoor unit. Indoor unit receives that 24 volts DC and sends back 12. And what we're doing there is establishing that serial communication. Now, things that can go wrong, right, when we are running that communication is cross wiring, right? So new installation related issues, cross wiring. If we run S2 to S3, right, S2 on our outdoor unit to S3 on our indoor unit, we'll run into problems. If we cross, S1 and S3, we'll run into some major problems. So making sure that we have that polarity, that we're landing on the same terminals on the indoor unit as we are on the outdoor unit, will verify that we have that proper communication structure.
And that, by the way, Clifton, is probably one of the top 1 or 2 calls is the cross wiring. On initial startup, with an initial installation, they go to start it up, they can't figure it out, and it's I'm gonna say it's very common, it's unfortunate. You just gotta double check. The wires should be color-coded, and they gotta match in outdoor and indoor, the same colors, S1, S2, S3. If it's black, red, white outside, it's black, red, white inside.
Types of wire and correct insulation on the wire is absolutely critical. I encountered a scenario a few years back. I had a new construction site. It was actually a dorm for a large college, and they had the construction of it was all ductless systems for each individual unit. And so as they were doing the construction, they were building the floors one at a time, and they were pulling all of their cables through the floor as they were building onto the next level. And so they were exposed to water, as they were building these levels. And upon commissioning of the systems, only about a third of them actually worked. And so I went out to do a job site investigation because we thought, wow, we do have a lot of communication circuits that are acting up. I mean, do we have a run of equipment that had failures? And when I got there, I immediately realized that we actually had a 14.3 MC cable for every single run, solid copper inside of a metal sleeve, non-water resistant cabling. And it was installed throughout the entire winter. And so in spring, they tried to fire them up, nothing worked. And as we're investigating this, I'm looking at the MC going, you know, I think we're going to have to tear some wire out and investigate here because I have a theory. They're like, "What is your theory?" I said, "Well, for one, you've used the wrong wire, but here's my theory on what the scenario is. I believe that this MC cable collected water as the construction of this project was happening, and then this last winter, all of that water froze inside of the MC cable, and ice shards punctured through the insulation of those solid copper conductors, and we began corroding copper." And we lost our DC communication. And they said, "Well, we have all of our voltages here." I said, "Well, you have voltages, but are you getting the proper communication?" So I went to the roof and I threw a brand new piece of the correct cable from the roof down to the unit that they were working on, and immediately started working. So it wasn't the fact that the copper had poor connections. It wasn't the fact that it was solid versus stranded. It was simply the fact that we had penetrated through the insulation by using the wrong cable, and the corrosion was enough to interfere with the DC communication. And my mind just went, wow, how common is this?
It doesn't even need the water or corrosion. I had a similar case early on with the communicating where I was smarter than the manufacturer. I used solid wire instead of stranded. And after a couple of years, there was a communication issue. And with the solid wire, I'm in New England, so it gets cold, it gets hot, it gets cold, it gets hot. The wire's copper, expands, contracts. You get these little micro fissures in that wire. And that in itself is enough to stop communication. So just the cold air, just the contraction and expansion of the copper, creating those cracks, that's enough to stop the communication. So if the manufacturer says, use an X gauge stranded wire, use that stranded wire. In fact, on our commercial, on our VRF equipment, the communication wire is a 16 gauge, 2-conductor, stranded, shielded, period. Anything else, and we don't know what we're going to have for communication. So follow the manufacturer's instructions. Please don't be like I was and say, oh yeah, this should work.
But this wire's on sale and it's the same size. Sure. Fine. Which I imagine was the scenario in that construction because it had like 160 ductless systems over a 3-winged building, 4 floors. And, if you look at the grand scale of things, that MC probably was cheaper than running the actual insulated ductless cable that we recommend. But in the long run, they had a mess on their hand and they had to run 160 external chases to be able to get the wiring on the exterior.
And there's another thing that you have to consider too with communication. You don't want that too close to an electrical source because now you could pick up that electrical source if it's too close and it'll interfere with the communication. So there's a reason we want it run in a separate conduit, communication versus power. We don't want to run those together.
Yeah, absolutely. Well, that's pretty intriguing. Can you imagine if we got this podcast out to the entire HVAC service industry, and all of a sudden, half or more of those technical support calls disappeared? We could all spend more time doing training, couldn't we?
That's the key, and training is the key. This is, and this better than anybody, Clifton. This is not an industry where I can just go to school and go to work and stop learning. Things change. You always have to go to training. You and I are in the same business. We're all in the same business. It's training with HVAC industry. So that's what we do.
So true. Well, when we started talking about the 2 primaries, we also mentioned condensate issues. So what types of calls do you commonly get for condensate technical support?
Yeah. So when it comes to our equipment, we have 2 different ways of managing condensate. With some of our ceilings suspended or any of those concealed units where we're actually up into the ceiling, whether it's a ducted unit that's supposed to be up in an attic or it's one of those flush mounted 1-way or 4-way cassettes, we have a way to manage that condensate by using what's called a lift pump.
Hmm.
And then we always have gravity drain as our second option.
Right.
And depending on our unit, we may have an actual float switch that sits inside of the drain pan.
Makes sense.
And that's just your standard float switch. If that drain pan starts to fill up, it's going to bring that float up, open that switch, and it's going to signal to our system that we have too much water in that drain pan. We also have in some of our units what's called a drain sensor. And that drain sensor essentially is like a thermistor. So every 60 seconds, it will heat for 30 seconds. And when it's doing that heat test, what it's essentially looking for is a change in temperature. And if we see that change or that drop in temperature, it knows, okay, I'm in water. I'm floating in water, and that's a problem. So with our units that have lift mechanisms, typically they'll have a drain sensor in there because it allows for that lift pump to eject that water. So the way that it's signaled is that drain sensor sits in the pan, it detects that change in temperature, and it's going to do that 2 more times. It's going to give it that 60-second cycle, check for temperature, 60-second cycle, check for temperature. If that temperature doesn't come back to normal, it's going to throw an error code. So there's two different things that could cause that, right? One is we have a failure of our drainage, right? We are actually backing up. That moisture, that water or condensate has actually filled the pan. And because of a pump failure or a blockage in our condensate, we are filling up that pan. The other time is component failure, right? These are safeties, and safeties are prone to failure. And so we could have a float switch that gets stuck in the closed position. And then we have our drain sensor, which again is a thermistor, and thermistors don't last forever. Eventually, they will go bad. And so when it comes to how do I figure out, is this an actual condensate management issue or is it a component issue? It's as simple as utilizing our service manual, getting those thermistor values and saying, is this thing reading normal? If I ohm this out, is it reading what it should be reading for temperature?
Exactly.
And then with a float switch, it's even easier. Do I have continuity?
Right. Am I open?
If I have continuity, it's functioning. If it's showing open all the time, that's it, right? That component. So that part of it is easy. Checking for component function is fairly easy. When we do have the backing up, we do actually have water collecting in that drain pan. We have to figure out what it is. If it's a failure of that lift pump, we need to figure out what's the proper voltage going to that lift pump. Do I have the proper voltage? Verify that it's actually ejecting water. And then on top of that, verifying that we have clear drains, because that was a big problem when I was in a van, was having clear drains. They get blocked up, right? They're almost always run outside. Very rarely, are they put into a floor drain in the residential world. They're a lot of times just run right outside. And so they're prone to having dirt, bugs, animals, things climb up inside of there. And then also just the nature of standing water, we start to get microbial growth, and that can start to create blockages. So that's our next step is, are we even actually ejecting that water? If all my components are functioning, is the water actually being removed, or is that why that water's backing up?
And there's something I've seen a couple of times on those units that we have where there's a water lift up mechanism. It's designed to pump up and then over, and then from there go gravity. And in the installation instructions, it gives you dimensions on the maximum lift that that pump can handle before you turn. And I've seen this happen actually quite a few times. If you exceed those limits, these pumps run continuously as long as the unit's in cooling or dry mode. So when you switch the mode, the pump stops running. And if you exceed those dimensions, then there's more water in that pipe than that pan can handle. So when you go to cycle off, that pan fills up and overflows. So it's all about reading the manual and installing it to the proper specs.
I know when I've been doing product selection, I have found that there are a variety of different models that have different lift heights depending on the construction. And so I completely understand and agree that it's critical to look at that manual to make sure that we're installing it with the correct lift height. Because if we installed one model on Monday and then on Tuesday we're installing another model, we're using the exact same lift dimensions, we may be in a completely different scenario where we have now overshot the maximum lift in exactly that scenario. We have created a space that allows more water to be in that vertical stand than what our pan could hold. And so it's not that we have a defect in the pumping system or the pan itself. It's a fact that we have a defect in the installation height of our lift that's causing the scenario.
Yeah.
I completely understand why it could be the second most highest technical support call coming through. Wow. That's intriguing that we only have two primary functions out of all of those that we can focus on.
Something else that we can focus on too, and we've actually done a podcast on this before, and I'm not going to say this is not a common call that we get. Typically, we discover this when there are issues, and we'll see a compressor replacement, and then a short time later, another one. But one thing that we're seeing a lot of is debris in the system. And this goes back to just basic best practices, piping best practices. And I can't emphasize this enough, but we found, when we have a site where the compressor goes and then it goes again and it goes again, and, we'll take them out and we'll inspect them. The engineers will cut them open, and we're finding copper shavings. We're finding sawdust. Silica is a big one. Sand. We found sand, I was on a job site here locally that was roughed in. It was being roughed in, and there was copper tubing sticking through the roof with a piece of electrical tape on the end of it. that piping needs to be sealed. It needs to be tight, dry, and clean. And I've heard horror stories of people dragging line set across the ground as they're running it, and there's no cap on the end of it. So ACR is clean and it's capped on both ends. So we see that a lot, and that's just unfortunate. So it's just best piping practices is another thing that it's for some reason it's almost like an epidemic in the industry.
Yeah,
The post-it epidemic, but that's
I've seen too many of those social media posts where technicians have installed filter dryers on ductless systems, thinking that they're doing a benefit to it and not realizing that most systems don't need a filter dryer. Those systems, if they're installed properly, they simply need a screen that would capture any type of debris that would protect things like an electronic expansion valve, which is why so many of our ductless systems and our commercial units have went with just screens instead of filter dryers. If there's no moisture and debris in the system, we don't need to have a filter because we're just adding restriction onto our system and reducing capacity.
right. And again, getting back to best practices, it's flowing nitrogen when you're brazing. We can't use soft solder anymore. It's got to be brazed. And when you braze, you get that oxidation on the outside of the pipe. It's on the inside of the pipe as well. I know I'm covering basics here, but when that oxidation builds up and you get the POE oil, cleans that right off, it's going to plug those strainers. That's a common issue. Again, it's not something that we'll get a phone call on. It's something that we discover later on when there's an issue, if we send somebody out to help the contractor. So not exactly a common phone call, but it's a common issue.
Common concern, absolutely.
I mean, just speaking for myself, I was in a van only a year and a half ago, and charge related issues were typically, what I was dealing with on a service call. I mean, nowadays, with how far heat pumps have come, they're relatively reliable. It's not common to be changing components. Over 5, 10 years, you might have to replace a thermostat or a motor here and there, but by and large, they're very reliable pieces of equipment. But charge related issues were things that I dealt with on almost a daily basis. And that can be, low charge or it can be overcharge. And both of those, in my opinion, are signs of improper practices. If we walk up to a system that's undercharged, unless a leak developed due to corrosion, typically that has been there since the install. And, speaking from personal experience, we had tried using flares on our installations. We had tried using mechanical press style connections. We tried using, things similar like shark bite style fittings, any connection that you could think of brazing. And no matter what style they chose, I still found myself going back on some of those new installations and tracking down leaks. So is it actually the method in which we're making our connections? Of course not, right? It has to do with making sure you're taking the time to verify that you are making a proper flare, that you're prepping the pipe properly when you're making a, compression style fitting. It's making sure that you do a pressure test and you give that pressure test time. And so, that part of it will result over time in these undercharged situations where a unit was installed 6 months ago, no heating, no cooling, and now you're there trying to figure out where did all this refrigerant go and why. And then on the other end of the spectrum, overcharge, right? How do we get a system that gets overcharged? It's typically because there's either a lack of understanding or lack of taking the proper care to go, this is a heat pump system, right? This is an inverter system. It's critically charged. There is no guessing, right? We can't use superheat and subcooling and hook up our clamps and our probes and say, yep, this is how much refrigerant it needs. We can't do that anymore. It's a critically charged system. And so if we're not taking the steps to verify what that charge is, and we're just kind of dumping some refrigerant in there to get them going, in some cases, on a Friday afternoon, I understand, but we shouldn't be leaving that system that way, right? We should be at some point making sure that we get back to that job site, verify where that leak was located, and verify what the proper charge for that equipment is.
And the important thing about that charge, you could be undercharged and the occupant, the end user, will not realize it right away. We did some testing in here, the local Mass Save folks that were affiliated with them several years ago. They came in and we removed half the charge from a 1-to-1 wall unit. And the Delta T was fine, the superheat was fine, the cooling was fine. It was working fine with half the refrigerant charge in there. But what was happening to the compressor? It was racing at high speed. So these are variable frequency, variable speed compressors. They're going to ramp up and ramp down based on the load. Well, with less refrigerant, it found itself ramping up. So if this was in a home, the homeowner wouldn't notice this until they got their first electric bill. And they would say, hey, why did this spike up? And then it's low on charge. And like Bryn said, these are critically charged systems. It's got to be weighed in.
No, absolutely. Fantastic stuff. Paul Chaves, Bryn Raptor, Mitsubishi Electric Trane, we're grateful for you joining us today. How can our audience learn more about Mitsubishi Electric Trane and the Metis Tech Show?
Oh, the Metis Tech Show is available on any podcast player. You can just search Metis Tech Show. So Bryn's one of my trainers. I lead the training department here. I got probably the best team in the company. With great trainers on here. For more training, it's MitsubishiComfort.com. You go to the For Pros tab, you hover over it and hit training. There's e-learning out there. Bryn and the guys have made something called Tech Links. We take little tidbits of information for specific things, like an LEV. How does that work? Just to give you an example.
Sure.
And we keep adding to that. Every year, we're putting more and more videos on there. We have plans to make a lot more. There's classes that you can take at one of our 10 training centers in the country. We have another one in Mexico. And on our distributor level, we have like 115 training centers as well. They teach the same things that we teach. So a lot of training out there available if you want it.
Fantastic. All right, guys, appreciate you joining us.
Yeah, thanks, Clifton.
Thank you, Clifton. Take care.